This is another video in our series on quadratic equations, and in this video we're going to continue to talk about perfect squares quadratic equations. Perfect squares quadratic equation is a quadratic equation. See, this is a quadratic equation. First term is a variable squared. That's how you know it's a quadratic equation. A perfect squares quadratic equation is a quadratic equation where the two factors, the two parts that you multiply together, the two factors are exactly the same. It's a plus 3 and the other factor is a plus 3. We multiply these two factors together and you get this quadratic equation. Now, what we especially like to look at in this video is that this term here, this number in the middle, the plus 6, is 2 times 3. Notice that the second term here in our factor is a 3. Well, this is the way it always is, that the second term inside the parentheses, the number there, 2 times that number is the number in the middle, and the second term here inside the parentheses, this number here squared is that last term. So 3 squared is the last term here, and 2 times 3 is the middle term there. So it's all because it's driven by this number here, the second term in your factor. So notice that the two different ways we're writing our factor is either a plus 3 times a plus 3, or the other way to write it is a plus 3 squared. Okay, so let's look at our first example. Okay, this is a quadratic equation. You can tell because the beginning of the equation is a variable squared, the second power, the exponent of 2. So you know this is a quadratic equation. But unlike a normal quadratic equation that we've been solving all along, there aren't 3 terms. You expect 3 terms in order to factor your quadratic equation. Well, there's no third term here. There's the beginning term, a squared. There's the second term, 14 times a constant times a variable. But the third term is gone. It's missing. So what we need to talk about here in the completing the square form of a quadratic equation is how do you add in this third term so that you can then factor your quadratic equation. So where do you get the third term from? Well, let's go back to what we just talked about a second ago, is that the middle term of a perfect squares quadratic, we're going to turn this into a perfect squares. So we want completing the square form, we want a perfect square. So the middle term is going to be 2 times the second part inside your parentheses of your factor. All right, so let's look at this. This thing here, if we take this 14, divide it by 2, 14 divided by 2, you get the number 7. Now to get the end number that you're going to add in here, you're going to get 7 squared. This is just like what we were talking about on the first page. 7 squared is 49. So the number that you're going to need to add in here, just to cut straight to it, is this 14 divided by 2 and then square it. So let's take the 14, divide by 2, and then square it. So 14 divided by 2 is 7. 7 squared is 49. So we need to add us 49 to the end of this quadratic equation. But if you add 49 to one side of the equal sign, you've got to add 49 to the other side of the equal sign. So we're going to add 49 to both sides of the equal sign. Well, 0 plus 49 is just 49. So on this side of the equal sign, you get 49. And on the other side of the equal sign, you get a quadratic equation that looks like a quadratic equation that we can solve. We put it into a puzzle box and we can solve it. Because it's got all 3 terms. It's got the a squared terms, the variable squared. In the middle, it's got a constant, 14 times the variable. And our last term is just a constant, 49. So to use the puzzle box, we're going to take this last term, put it on the top. And we're going to take the middle term, the plus 14, and we put it on the bottom. Okay, now we have to figure the two things you multiply together to get to 49, and you add them together to get to 14. Well, what do you multiply to get to 49 and add to get to 14? Well, we should already know in advance what the number we're looking for is, because here it is right there. It's that 7. Because we knew that the thing inside of our factor is going to be a plus 7. Right? Because half that 14 is 7, and that's the thing that goes inside your factor. So our two factors in, plus 7 and plus 7. So writing it out, it's a plus 7, a plus 7. There's the 7 right there. The second term of your factor is a plus 7. So by cutting this 14 in half, half of the 14, it gave us the answer to what the factor is going to be. Okay, so now looking at our quadratic, we have quadratic equation here equal to 49. So then by factoring our quadratic, we now have the factors are equal to 49 because the quadratic equation was equal to 49. So now then the factors, which are equal to the quadratic equation, when you factor that apart into these two parts multiplied together, these parts are now equal to 49. So the other way to write this is the exact same thing because your two factors are exactly the same. It's an a plus 7 and an a plus 7. That's another way to write a plus 7 squared. And there it is. We have now used completed squares form of a quadratic equation. We took this quadratic that we originally had, we had to add something into it, and now this is our answer. A plus 7 squared equals 49. Okay, so now we're going to try some classwork problems, and they're just like this one. You're going to have to complete the square, meaning you're going to have to add something in to your original problem, add something to both sides, so that you can then run it through your puzzle box and get back the completed squares version of your quadratic equation. So you may have to watch this video, example 1, over again while you're working your problems. You have to go back and watch the example 1 over. But let's have a look at the questions, Classwork 1, and see if we can do, for this problem, exactly what we just did in the example. We're going to have to add something to both sides, and then we'll be able to run it through the puzzle box to get our completed squares form of a perfect squares quadratic equation. Okay, so you can pause the video now, and you may have to go back and watch example 1 over again, but come up with your answer and I'll compare it to my answer. So pause your video and work it out. Okay, let's have a look at my answer. Okay, the number that I said you needed to add to both sides was right there. It's a plus 64, right? The way I got my plus 64 is I cut my 16 in half. What's half of 16 is 8. And then I squared 8. 8 squared is 64. So you cut that in half, then you square it, and you add it to both sides. This is a completed squares form of quadratic equation. Okay, so then I ran this through the puzzle box, and I came up with a plus 8 squared equal to 64, because I can factor this equation here into a plus 8 times a plus 8. Okay, so time for another problem. Pause the video, work this problem, and then we'll look at my answer. Okay, here we go. My answer, the number to add into both sides, I said plus 25 to both sides. Why did I say plus 25? Because look at the number in the middle. It's plus 10. And what's half of 10? 5. And what's 5 squared? 5 times 5 is 25. So that's where I got my 25 to add to both sides. Okay, once I've added my 25 to both sides, I now have this quadratic equation. I'm going to run that through a puzzle box, and I come up with a plus 5 times a plus 5, or a plus 5 squared. Okay, so that's a perfect squared quadratic, and it's equal to 25 because when I added 25 to both sides, I ended up with the 25 on this side of the equal sign. Okay, pause the video again, and we'll try this next one, and then you can look at my answer. Okay, let's look at what I got. Okay, the number I added to both sides is plus 4. Why did I say plus 4 added to both sides? Because take the number in the middle, it's a plus 4, divide by 2, that'd be plus 2, and then square it. 2 times 2 is 4. That's why I decided to add 4 to both sides. So I added 4 to both sides. I now have this thing here, and this thing here is a perfect squares quadratic equation because it factors into a plus 2 times a plus 2. That's what this part here is. So a plus 2 squares is that. Now this was equals 4, so therefore the two factors, a plus 2 squared, is equal to 4. Okay, let's look at another example. So in this example, example 2, same thing over again. Okay, we have a quadratic equation. You can tell it's quadratic because the first term, first thing added together here, is a variable squared. That makes it a quadratic equation. Okay, but we're missing our third term. We have this thing, we have the second term, minus the 10a, But the other thing, the thing you add in here, is gone. So we're going to have to add it in ourselves in order to complete the square. Complete the square by adding the thing that's missing here. So what's missing? How do you know what's missing? Well, same thing over again. You take the middle thing here, the minus 10, and you divide that minus 10 by 2. Minus 10 divided by 2. Well, minus 10 divided by 2 is minus 5, because half of 10 is 5, and just because you divide it by 2, it doesn't stop being negative. It was negative before you divided it, it's still negative, so you have negative 5. So what is negative 5 squared? Negative 5 times negative 5. 5 times 5 is 25, and negative times negative is positive. So you end up with negative 5 squared is equal to 25. So the number I want to add to both sides here is 25. And so I add 25 over here, add 25 over here, and you end up with this equation here, which is a perfect squares quadratic equation. How do I know it's a perfect squares quadratic equation? Because the way we made it. We created this equation because by adding exactly the number in here, what would cause it to become a perfect squares quadratic equation. So we take this perfect squares quadratic equation, we run it through the puzzle box, and we find out what the two factors are. So plus 25 goes to the top of the puzzle box, minus 10 goes to the bottom, and on our two sides, what do you multiply together to 25? Well, 5 times 5 is 25. Okay, the number on the bottom is negative. So if the number on the bottom is negative, then you know that at least one of these two sides has to be negative. But because you multiply two negative numbers to get a positive number, we know that both these numbers have to be negative. It can't just be one of them. So we end up with a minus 5 and a minus 5. So we take these two numbers, put them into our two factors, and the second term of the factor is a minus 5. Well, that's what we predicted from up here. We predicted when we took minus 10 divided by 2, we predicted that the factors were going to have minus 5s in them. And here they are. Okay, so the quadratic equation, this is a perfect square, and so the equation was equal to 25, for therefore, two factors is equal to 25. And another way to write this, because the two factors are exactly the same, is a minus 5 squared equals 25. Okay, so that's example 2. So let's look at some more classwork problems. And if you need to, come back and watch this video again on example 2 and try the classworks for yourself. So let's look at the classwork problem. Here you go. This is exactly the same problem. It's a quadratic equation, but it's missing the third term, the third thing being added in here. So therefore, we're going to have to figure out what's missing and add it in to both sides. So pause the video, give it your best try. If you need to, go back and watch example 2 again, and then come back and look at my answer and compare it to your answer. Okay, let's have a look at what I got. I got a minus 7 squared equals 49. Okay, let's try another one. Give it a try, pause your video, and then come back and we'll look at what answer I got. Okay, let's see what I got. A minus 6 squared equals 36. Notice that the middle term here, minus 12, what's half of the minus 12? Half of minus 12, half of 12 is 6. So minus 6. And look here, inside our perfect square, the second term inside the factor is a minus 6. How come? Because minus 12 divided by 2 is minus 6. Up here on the first problem, minus 14 divided by 2 is minus 7. So you can figure out what's going to be inside the factor of your perfect square just by dividing the middle term by 2. All right, let's try the next one. Same thing over again. Figure out what to add to both sides, run it through the puzzle box, and get your factors. Okay, let's see what I got. See if it's the same as what you got. Half of minus 4 is minus 2. There's your minus 2 right there. And the number that I added on was minus 2 squared, right? Half of minus 4 is minus 2 squared is plus 4. Okay, example number 3. And again, we have a quadratic equation. We're trying to do a completed squares form of the quadratic equation, right? So we're going to complete the square, meaning we're going to add what we have to add to both sides in order to complete the square. The only thing a little bit different about this one than the last one is notice that this isn't equal to 0, it's equal to a 5. That makes no difference at all. The point is that we're missing our term on this side, the third part, and we're going to have to add it to both sides. The fact that there's already a 5 over here doesn't affect that we still have to add a number to both sides. We just have to figure out what we have to add. Well, what do we have to add? Well, same thing we've been doing. Take the plus 12 divided by 2, plus 12 divided by 2 equals 6. Okay, then take the 6 and square it. 6 squared is 36. So the number we're going to add to both sides is 36, plus 36 on this side, plus 36 on that side. Now, on this side here, this side of the equal sign, we already had a 5. So 5 plus 36 gives us 41. So that's where the 41 came from. Okay. All right, now this thing here is going to be a perfect squares quadratic equation. How come we know it's going to be perfect squares? Because we made it to be. The way we made this equation, figuring out what this third number was, makes it have to be a perfect squares quadratic. By doing this little bit of math here, dividing the middle by 2, and then squaring it, we've created something that has to be a perfect squares quadratic. But let's check it anyway. We run it through the puzzle box, and that number there goes to the top. That number there, plus 12, goes to the bottom. And our two sides, what times what is 36? And you add the two sides to get to 12. Well, 6 times 6 is 36, and 6 plus 6 is 12. So then we get our two factors, a plus 6 and a plus 6, and we shouldn't be surprised that the factor had a plus 6 as its second term, because we did this little bit of equation here, we got a 6 back. Half of the middle, half of that 12 was a 6, and sure enough, in your factor, you have a 6, because this is a perfect squares quadratic. In a perfect squares quadratic, half of what's ever in the middle is in your factor. Okay, so the other way to, since the two factors, since the equation itself is equal to 41, then the two factors have to be equal to 41. And another way to write that is a plus 6 times a plus 6 is a plus 6 squared. And this is your completed squares version of the quadratic equation. So let's look at some more classwork problems. And here they are. So same thing over again. Complete the square, figure out what number you have to add to both sides. Then run it through the puzzle box to turn it into factors. And that'll be your completed squares version, completed squares form of this quadratic equation. So pause the video, do this first problem, and then we'll come back and look at my answer. Okay, let's see what I got. A minus 7 squared equals 58. Okay, let's try the next one. Pause your video, and then we'll come back and see what I got. All right, what I got was a plus 4 squared equals 19. And notice that half of negative 14 is negative 7. Half of 8 plus 8 is plus 4. Okay, for this next one, pause your video, do this next one, and then we'll come back and see what I got. Okay, let's see what I got. Now, not surprising, half of 4 is 2. Okay, that's it for today. Thank you for watching this video.